Okay, so in this video, as promised, I made a minor change in the configuration. We've been talking about series circuits. Now let's a little bit talk about parallel. I like the light bulb example because it gives us the best examples. So in this case, I have actually 3 bulbs wired in parallel. Okay, now the key is if I unscrew one of these bulbs, the rest of them don't go out. Okay, I can unscrew 2 of them and the rest won't go out. I can bypass or turn the power off on any one of the others and the voltages are going to remain the same. You notice they didn't go brighter or dimmer. So I have full control over each bulb. Now if we take a look at voltage, okay, so coming in from source, I still have my 123. At bulb 1, I have 123. At bulb 2, I have 123. Bulb 3, I'll still have 123. So again, in all of our areas, we have the full source voltage. If I turn switch 2 off, okay, for the bulb 2, and I take a voltage reading across line, and the output of switch 2, that's where I'm going to get my higher voltage. Okay, and if I have that bulb turned on, the switch is closed, so I'm going to have 0 volts. So the key with parallel circuit is no matter how many bulbs you have not running, okay, the remainder bulb is still going to have the same voltage. Okay, so I have 123. If I turn that bulb back on, okay, I'm still going to have 123 because every bulb is getting source voltage regardless of how many bulbs you have off and how many bulbs you have on. So that is series parallel. Okay, series control circuits, parallel circuits that do work because they all get full source voltage.